Hi guys, we're here in Denver at SuperComputing conference. I'm here with Ty from Nvidia, and we're going to be talking GPUs. Ty, thanks for doing this.
Hi, Karan. Hi.
Yet again. Take two. So why don't you introduce the audience, introduce yourself to the audience.
Yes, so my name's Ty McKercher, Director of Solution Architect and Engineering. I help manage a team that covers various verticals across North America, Latin America.
And oil and gas is our favorite topic.
So I focused on oil and gas. I've been at Nvidia 11 years.
Wow.
Or over 11, and I focus on oil and gas.
Cool, so let's talk a little bit about some of the things that people are doing in oil and gas with GPUs, specifically with Nvidia.
Yeah, when I started, there were no GPUs in the data center, and now there's thousands of them. They're doing seismic processing, so the upstream, so when you gather the data, to be able to process the data, and from that try to extract features that you can use to help identify where to drill for oil.
Right. Okay, cool. And then mostly it's all upstream, so lots of simulation, lots of computation, lots of data, right?
Yes.
I mean, especially in oil and gas, the data is huge, ginormous, right? What kinds of...
So the best bandwidth is a truck going down the highway with tapes of data still.
Wow, tapes still today?
Yes.
Oh my God.
Because of the volumes of data.
Right.
There's also disk subsystems, but it's huge volumes.
Right.
For every experiment, they gather many terabytes, and there's many experiments in any one survey.
Right, and what kind of ISVs are enabling GPUs to sort of...
Yeah, that's a great question. We focused on some of the primary ones like Schlumberger, Halliburton, Paradigm, and they have a whole suite of applications, and we've helped refactor their code to use CUDA and GPUs for various parts of that upstream workflow, from processing the data to interpreting it, even some of the reservoir simulation is accelerated now.
Interesting, and then it's all upstream, and we talked a little bit about edge as well off camera.
Yeah.
What are some of the interesting ways that they can use the edge?
Yeah, so it's the problem is upstream, and then there's a midstream where you're transporting it, and then there's a downstream that goes all the way out to the consumer.
The consumer, right.
And we focus mainly on the upstream, but there is now emerging opportunities in the mid and downstream, and edge matters. If I'm capturing a lot of time series data coming out of a well, I want to be able to process that data at the edge and get the right information to the right teams at the right time to avoid what they call non-productive time, NPT.
NPT, yeah. That's my new favorite word. It's the one that I learned this year.
These are expensive systems, and if they're down, they're not recovering the hydrocarbons. It can cost many.
Right, and NPT is across the board, right? It can be machinery that's potentially needs to be fixed, and then you're using ML models to be able to predict the maintenance.
Yes. So again, if I can identify some of the characteristics of a submersible pump that is surpassing some kinds of thresholds, using neural networks, I detect that pattern, and then get the right information right before those pumps go out. That can make a huge difference for some of the mid-tier and
It could be anywhere from thousands of dollars to millions if they don't actually use this, right?
Absolutely.
Wow, and we know oil and gas, they care about money, right?
Yes.
So, interesting.
Safety is another factor, and anytime you can classify and predict, use neural technology, and AI technology to help in that workflow safety, and identify outliers, something that's not normal. Get the right information to the right people so they can have that insight and act on it.
Right, and between the three different tiers, right? Upstream, midstream, downstream, which is most, I guess, cloud friendly out of the three, or is there one or the other, or?
Yeah, great question. I was surprised at how Schlumberger moved to a cloud offering, and I didn't think they would to do some of the upstream elements of that. I think that it's, again, data is really critical, and having security and being able to deliver that in a cloud, it's proven that it can work even with upstream. I think there's even a more natural for some of the mid and downstream kinds of.
But it's early days, you think?
Still early for that, but it's more of the similar kind of workflows that are already enabled in the cloud, and it seems like a potentially natural extension.
Right, so we were talking offline before some of the cool stuff you've got going here.
Yeah.
Very, based on your history, graphics, and visualization. In fact, speaking oil and gas, me and my guys are playing around with OpenDTech on one of our V100 GPUs.
Yes.
So what are some of the cool things you've got going here?
Yeah, so one of the technologies that we're kind of highlighting is a new technology called GPU Direct Storage.
Feeding data to the GPUs.
Feeding data from disk subsystems.
Right.
We've been doing this for many years through NIC and
GPU Direct.
GPU Direct RDMA through the NIC, and if you can avoid having to copy that through host memory, GPU on one node can share data across networks to another GPU without having to go through host memory, avoid those extra costs and latencies. It's a big win. We've been doing that with RDMA. But
that's across nodes, not a single server.
That's right. And what we're showing today is the ability to do this with storage. So if you have NVMe local, instead of having to copy that through the CPU and then down to the GPU, you can
directly
go
to the CPU.
And if you have a parallel file system with a NIC connection, you can get direct from the parallel file system directly into GPU. We're also exposing some APIs that are very familiar, like POSIX read write type APIs, but allows the GPU direct storage.
So what kind of distributed file systems is anything supported, like Lustre, Weka IO?
All of the big ones.
All of the big ones.
Yeah, DDN is another.
Spectrum Scale and all these. Okay, got it.
We're working, and it's early days, but we're working with all of them to be able to integrate this into their stack where it makes sense.
Right. So the NVMe stuff is cool, but then you've got the NASA image on top of it.
Yeah. So what's going on behind the scenes here is that's quite a bit of data to be visualized. And we're simulating what it would be to be able to land humans on Mars. And so the problem is so big it doesn't fit in a single GPU, it doesn't fit in multi-GPUs within a server. It takes
like
a
cluster or a pod.
Exactly. And what Index is a library that allows you to break the problem up so it runs on a cluster of GPUs. And then coalesce that data back for a visualization that can be displayed, one screen, or it can actually be streamed out through an interface so that you can interact with the data and collaborate with very, very large volumes that reside in data.
Well, the one problem you have solved for me is cool demos for SPC.
Yeah. Yes.
I've been playing with CLIs and code running up and down. Now I can do this and be like, by the way, it's all NVMe.
In this particular case, the Index demo, they were reading data just off a disk to initialize the volumes, and by doing GPU direct storage, they got I think a 3 to 5x up. I can't say for sure the exact numbers, but it was significant. So it's very, very large promise. Trying to remove those bottlenecks. I/O, feed the beast, if you will. And every release, we're trying to always lower the hurdle for adoption.
Well, we could go all day, but I'm going to cut this off right here. So thank you again, Ty, so much. And join us another time for another episode where we'll talk more geeky stuff. Thank you.